and welcome to another episode of DFS on Technology. In this episode, I'm going to look at this thing, which is a bObsweep Vision Plus robot vacuum cleaner. I bought this a few months ago because, like most people, I'm lazy and try to avoid housework. So I figured, well, I'll get a robot to do the vacuuming for me. Overall, how did it work out? Well, I think robot vacuum cleaners are kind of like fruit-flavored herbal teas. They sound great in theory, but in practice, they're invariably disappointing. The one thing that I do like about this unit, though, is that in addition to being a vacuum cleaner, there's an attachment for mopping up floors. It's a little tank that you fill with water, has a cloth underneath, and it runs around your floor mopping it. And I actually find that to be pretty good. I don't mind vacuuming, by hand, but I don't really like mopping my floor, so mostly I use this thing as an automatic floor mopper rather than a vacuum. So within days of buying this thing, I started to wonder how it works and what's inside and what software it's running. And that's what we're going to find out today. So before I tear into this to get inside it, we should actually poke at it from the network. This is a network connected device, and you can often tell a lot about what a device is running by looking at it from the network. So let's transport over to the computer and see what we can find by probing this over the network. Okay, so now we're going to run nmap against the bObsweep to see what ports it's listening on. I'm going to look at the top 5,000 ports. So here it goes. And it's listening on SSH, MQTT, and that IRC isn't really IRC. That's an IoT thing port. I don't know what it's used for. Now let's try to do passive OS fingerprinting. Here it goes. Takes a little while. Okay, so we see OS details Linux, and we're running SSH, OpenSSH 7.6 to be precise. And yes, it thinks it's the Linux kernel. So more evidence for something Linuxy going on inside the bObsweep. Let's take a closer look at the hardware. The unit has a camera at the top. It's kind of hard to see, but if you look closely, you can see the camera. I don't know if this is used much in the actual operation, but it was used to set up the Wi-Fi network. Their app made a QR code with your network details, and the camera took a picture of it, and it set up the Wi-Fi, which is a pretty clever way of doing it, I think. There's a little bumper that has, as far as I can tell, 3 limit switches, one in the left, one in the right, one in the front, so it can detect when it bumps into things. If we turn it upside down, I've taken out the dust compartment. There are 4 little contacts that go to the dust compartment, and that's because it can also be a mop, as I mentioned. And I suspect these contacts are for the CPU to know which attachment is attached. My guess is it's an I2C bus with 4 connections. You got power, ground, clock, and data. There are 3 little sort of edge detector thingies that can tell you when you're about to go over a step, so that stops it from falling down the stairs. A couple of big metal plates for charging. Some spinny brushes that drag the dust into the path of the main brush. And these spinny brushes tend to get bent and warped and are actually not very good. We have the drive wheels, of course, and a battery compartment. This does have a replaceable battery, obviously, and a whole bunch of screws holding the thing together. So that's the hardware. All right, so once I found out that it was listening on SSH, I tried brute forcing a few obvious usernames and passwords like root1234, Bob, bObsweep. Nothing worked. They either don't have password authentication turned on, or they have harder to guess passwords. So next thing to do is to open this sucker up and see if there's a serial port on there somewhere where we can get a Linux shell. Most embedded electronic devices that have a Linux installation on them do have some sort of serial port for engineers at the factory to debug the device. So yeah, let's take this apart. Now, I have taken it apart before, and it takes forever. It's a real pain in the butt. There are lots of fiddly parts and springs and things that you have to be very careful with. So I'm not going to show that. It'll be like half an hour. So let me just open it up, and by the magic of filmmaking, you'll just see it opened up. Okay, with the bObsweep open, let's take a look at what's inside. The first thing we see is a lithium-ion battery. Pretty beefy, 3000 milliamp hours, 14.8 volts that can run at 44 watts, which is pretty good for a battery. We have the camera assembly up top with a little cooling fan. There are at least 5 motors. There's one for the left wheel, one for the right wheel, one for the one for each of probably those little spinny brushes that bring the dust in from the sides, and then one for the main roller assembly and possibly the blower fan also. We have a Wi-Fi antenna. We have a tiny little speaker that does some beeping and booping. One very interesting feature on the circuit board is the set of through holes. These look like they're for a couple of jumpers, and I bet one of them is for a UART to communicate with the CPU directly. Now, they're not populated, so they're awkward to connect to, but we can just populate them with some of these tiny little PCB test points, which are very cheap, a couple of bucks for 100, and we'll be good to go. Here we see the 2 sets of jumper through holes with the PCB test pins inserted. The CPU, it was kind of hard to get the markings on it, but it's a GD32F303 VGT6. This is an STM32 clone, and I found the datasheet for this chip. You can see from the datasheet that this particular chip has 1 megabyte of flash memory and 96 kilobytes of SRAM. Which is certainly insufficient to run Linux. So if there is Linux running on this thing, there's definitely external memory somewhere, which I didn't come across on the board, but on the other hand, I didn't remove the board and look at the other side, so there's that. This little chip here looks like an MP26124, which is a DC to DC step-down switching charger, so it's to charge the battery. This little chip here is the MP6515, and it's a motor driver. So I only found one of these chips on the board, and it looks like it can only drive one motor, so presumably there are more of these. I didn't see any on the top, though I might have missed some, so I suspect there's some chips on the other side of the board. I really should have taken it out and looked at the other side, but I'm too lazy to do that now. The next thing we have to do is figure out what the pin out of these jumpers is. I'm guessing it's one is ground, one is power, one is transmit, and one is receive. So let's first try to identify ground. Right now there's no battery in the device. This is probably ground here, this metal thing, and it seems to be connected to the other metal thing, so I'm pretty sure this is ground. So if we test these pins, okay, that one is ground. That one's ground also. And just looking at the PCB up close, I bet the middle two are transmit and receive, and these two here are power, 3.3 volts. But let me put the battery back in and we'll measure some voltages. Okay, the battery is back in the device. Let's power it on. Okay, we see signs of life. Now we know the top one is ground, so I bet this one is going to be 3.3 volts. Yep. And I bet this one's, oh, that one's, yep, 3.3 volts. that one's also 3.3, and that one's also 3.3. Okay, this one is showing 3.3 roughly. That's showing 0. That's showing 3.3. So if I had to guess, my guess would be that the UART is this row, because typically the transmit pin, when it's idle, is held high, so we'd expect to see 3.3 volts. And the receive pin probably has a pull-up resistor pulling it up to 3.3 volts. So my guess is this inner one is the UART. So we'll hook it up to a USB to serial port adapter and plug it into the computer and see what we can see. I have to figure out how to switch this thing off. Let's see. Press and hold. Looks like it's switched off. Okay, I have the bObsweep hooked up to my computer, and I had to put the cover back on because if some peripherals aren't connected, it gets angry when it boots. I also verified the connections and the baud rate before filming, so let's start our terminal emulator and let's boot the bObsweep. Exciting, it's printing stuff. Okay, it looks like some of it's written in C++ and some in C, given the extension on those file names that we're seeing. It's having a good think. Still thinking. The little happy I'm alive chime went off. Okay, it's printing some more debugging stuff. Unfortunately, it doesn't seem like we get a shell on this serial port. So it's just receiving heartbeat data, probably from another chip. And you know, this UART port might not even be to the main CPU. It's got STM32 there, which is a microcontroller. Oh, it got the UTC time. I don't know if you can see that scrolling up there. Whoops, there. The vacuum does have a feature where you can schedule cleaning, so having an accurate clock is good. I'm going to open another terminal. Let's drag this one over here, make the font a little bit bigger. Okay, move you over there. Let's see if I can ping it. Yes, it is on the network. Now, I can try SSHing in there, root at bObsweep. Let's try that. So, 1, 2, 3, 4. Nope. Root. Nope. All right, so we're gonna have to brute force this password with a program. It's not really feasible to do it by hand. All right, so let's power it down and I'll finish putting it back together properly. Hello. Well, it's the next day, hence the different t-shirt. I tried brute forcing the bObsweep password using a list of the top 100,000 most popular passwords found in internet breaches, and also just a list of English words, and I couldn't crack it. So I suspect either they're using a strong password or they're not even using password authentication at all. They're just using public key auth. So that was a little disappointing. I didn't try games like holding both buttons down or whatever to see if we'd get a debug console that's more useful. I kind of doubt it. I also didn't look on the board for a JTAG port. Firstly, I don't have the right equipment to do a JTAG scan. Secondly, I don't really have the expertise to do it. And thirdly, I found an article that I'll link to where somebody tried to do this on a different version of bObsweep, a different bObsweep product. And it was pretty locked down. He couldn't get anywhere either. So it seems like they do take the security of their software seriously. I also tried intercepting the network traffic between the bObsweep and the cloud servers, and it was all encrypted, so nothing useful there. The servers that it did try to contact belong to a domain called Tuya US, and some Googling showed that there's a company called Tuya that provides a platform for developing robotics, and so I think they're using that platform in their vacuums. The platform claims it is based on Linux and an RTOS, so I think there's definitely Linux somewhere in the guts of that bObsweep. Now I emailed bObsweep support asking for a copy of the source code to all the GPL software that they use on the bObsweep. I haven't had a reply yet. I don't think they will take kindly to my request because they haven't mentioned anything about using GPL software on their website. They haven't offered to supply the source code, which is a requirement if you use GPL software. So either they don't use GPL software, which I think is unlikely, or they're violating the GPL. So I will follow up on that. Anyway, that's my dive into the bObsweep. Hope you enjoyed it.